Hello friends, in this series of videos we are solving problems related to transactions and schedule management, concurrency control in DBMS. So we have already solved pretty much problems now on transactions and schedules to identify whether a schedule is serializable, whether it is a recoverable, whether it is a cascateless and all that. Again in this time I have come up with a problem, the same problem we have to identify whether the schedule is serializable or not, and if it is serializable we need to find the execution order. So we will pretty, since we have already solved, we have a handful amount of practice, so I would like you to give a handful practice on this so that you do not forget this topic anytime soon. So again, so these are the transactions, these are the operations. Again we will have to make a precedence graph. We know that to identify whether a schedule is conflict serializable or not. We start with read of d3. We see that there is any write of d3. Yeah, there is a write of d3. So there is a conflict between t2 and d3, and t2 has to start first before t3. Now we start go to read on d2. We see that there is a write on d2 over here. Yeah, there is a write on d2 over here also. So t2 needs to complete first, and again t2 to t3 was already there, so these conflicts are already catch before, so now we do not need to represent it again. I again see write on d2, and this will a conflict with read on d2, and also read on d2 and write on d2. So these both are also covered, t2 to t1 and t2 to t3. So we are done with these three transactions. We go on to t3. So read on d2, which will have a conflict with this write on d2 over here. So there is a t3 to t1 edge also forming up now. Read on d3 will have no conflict because there are no read or write operations on d3 in t1 and t2. It goes out safe. Read on d1, yeah, read on d1, we see that there is a conflict at write on d1, so we'll have to make an edge from t1 to t2. So at this point, if this was an MCQ question, I would have stopped over here. If there was no concept or no another questions being asked, if this was a true false question, I would have stopped it over here because I can find a cycle in the graph. I can find a cycle in the graph, and as soon as I find the cycle in the graph, I know that the schedule is non-serializable. So that's it for this problem. I think it was a pretty easy problem because we have solved complex problems previously. So I hope you like the solution, and in case if you have any doubts, comment it down. I'll try to solve them. Thank you for watching. Do not forget to like and subscribe to the channel. Thank you.